Objective. During this lab you will establish Hooke's Law and will find the value for the spring constant for two different springs. What is Hooke's Law? Hooke's Law explains the relationship between the force exerted on the spring, a stretch of the spring, and the spring constant of the spring. Springs are very special because they have a restoring force, which means that when a force is applied on them, they exert an opposing force to restore their original shape. The materials necessary for this experiment are one ring stand, clamps, rulers, springs, and different sets of masses. An example of the lab setup can be seen here. Procedure. For each of the two springs, 1. Attach the spring to the ring stand and have one of your group members hold the 0 mark of a ruler up to the end of the spring, usually a hook or a loop. For each of the 5 masses, 2. Attach the mass to the end of the spring. Measure the stretch of the spring by looking at the location of the end of the spring, and record this measurement in the provided table. Warning: too much weight on a spring can lead to permanent damage. Only add a little weight at a time. Demonstration. Sample data. A data table as such is provided to the students. Both springs have added masses of 0.1, 0.2, 0.3, 0.4, and 0.5 kilograms. To find the weight of each mass, multiply the value by 9.8. Example can be seen here. An example of the stretch of each spring due to the added weight can be seen here. Data analysis. For each spring, plot the applied force, F sub n. This is the total weight, m times g, of the masses, m, hanging on the spring, on the y-axis versus the corresponding stretches, x sub m, on the x-axis. An example for spring 1 can be seen here. An example for spring 2 can be seen here. 2. Draw a best fit line for each of your plots. Be sure to include 0.00. An example for spring 1 can be seen here. An example for spring 2 can be seen here. 3. Do these best fit lines approximate your data well? Yes or no? If so, then you've established Hooke's Law, F is equal to Kx. 4. Use the slope of the graph to find the spring constant. A, spring 1, K is equal to F over X, and B, spring 2, K is equal to F over X. Due to Hooke's Law, we find that the spring constant is 100 newtons per meter for spring 1. Due to Hooke's Law, we find that the spring constant is 150 newtons per meter for spring 2. Application questions should be answered as a class. Thank you for participating in this online lab. See you next time.